Hey guys, welcome to part one of the Sinister saw build. In part one, we're going to be dealing with the table portion of this build. And so first off, what is this thing? Well, it's a folding table and fence system that uses plates to interchange tools. And the plates are sort of similar to the throw plates on a table saw. We're going to be mounting different tools underneath to gain multifunctionality of this table. And the whole idea here is to save valuable space in my workshop because I don't have the space required for things like a dedicated miter saw stand, a dedicated table router, or a dedicated table saw. And so it's also going to save us money by building it ourselves, and we can use existing tools that we already own and incorporate them into this table to gain that multifunctionality of the table. Now, I've seen other videos on YouTube where guys combine all of their tools and they all exist on the workbench at once, and they're not really interchangeable. And I didn't think that was ideal for me because I think it really limits the size of the workpiece that you can work with. Because if you use a large enough piece of material, you're gonna start running into the other tools on there, like your jigsaw that's sitting behind your table saw fence or something like that. So it's really not the direction that I wanted to go in. And so the next thing is, why is it called the Sinister saw? And well, it's a little bit of a play on the word sinister, and that's because on the table saw portion, the fence is actually going to be mounted on the left side of the blade. And I'm probably going to get some interesting comments in the comment section down below about this, but to date it hasn't caused me any problems at all, and I've gotten quite used to it. Really, it doesn't really change anything in my opinion, but the reason I did it this way, and it's not because I'm left-handed, it's because of the circular saw that I'm using. So I'm going to use a cordless Ryobi circular saw and mounting it under the table. If I make a bevel cut with that circular saw, when I go to tilt the blade, it's very imperative that in a table saw, you don't tilt the blade towards the fence. You want to tilt it away from the fence. And the mechanism that the saw is mounted on, right from the factory, it only tilts one way. And so if you tilt it in that direction and you take into account the direction of the blade, I can't actually mount my fence on the right-hand side because if I make a bevel cut, it'll tilt towards the fence. So I was forced to mount the fence on the left-hand side, at least on the table saw portion of this thing. And so the last thing worth mentioning is you don't need to use a cordless saw for this build. If you are going to build a similar table, you can use a more traditional corded saw. I'm only using the cordless saw because it's what I had laying around and I didn't want to buy another saw. The cordless saw comes with its own issues of having to access the battery under the table. You really don't want to be reaching under the table, especially if the saw blade could be moving or could turn on accidentally. And so I solved that problem in the next video by creating a remote battery mount system that has an emergency stop button, and you can turn the saw on and off remotely so you don't have to reach under the table. That's in the next video, and all of the 3D printed files in this video, the next video, they'll all be found in the video description down below, so please check that out. You'll find all the drawings for all of the woodworking pieces. Like I said, all the 3D printing parts will be down there as well, so please visit that. And with all of that out of the way, let's get started. All right, so the first two parts that we're going to tackle here are the mounting plates for both the router and the circular saw. So I'm going to be using a Bosch 1617 router, and I'm going to be using a Ryobi cordless 6.5-inch circular saw. I've printed the template on an 8.5 by 11-inch standard size letter piece of paper, and I designed the plates to be exactly 8.5 inches by 11 inches so that you can just print off the template on a standard piece of paper on a 1:1 scale, and it can actually use the piece of paper itself as a template for the mounting plate. Since I currently don't have a table saw to make these rip cuts, I have this set up here between two sets of sawhorses and the 1/2-inch MDF tabletops here. You can see the piece that I've marked out that I'm going to cut. I'm going to rip through that. And this is just another piece of 1/2-inch MDF scrap that I'm using here. I've clamped down, and I've clamped it at the perfect distance to maintain that square edge. when I rip through. So this edge of this piece of MDF here provides a guide for my circular saw. So at this point, since I don't have a table saw, I just used my circular saw and took my time with the cuts to make sure that my dimensions were accurate and that the edges were perpendicular to one another. And so now we can take our templates and we can line them up with our pieces of wood, secure them in place with a small dab of a glue stick, and we're ready to mark our holes for drilling. And now I'm going to be marking the center of my holes with a sharp screwdriver, but you can pretty much use any sharp object you want to get those holes marked out through the drilling template. And now on the router plate, my 4 holes mounting my router are actually metric holes. I'm going to be using a number 8 countersunk bit since I don't have any metric countersinking bits to countersink those holes, and the metric screws should still fit through nicely. In the 4 corners of every plate, those are going to be number 10 screws, and these are all flathead screws so they sit flush with the table surface. And so I'm going to be hitting those with a number 10 countersunk bit. And then you'll notice on the drilling template for the circular saw, there's some larger holes, and those are going to be meant for some T-nuts. I'm going to be securing the circular saw from the bottom using T-nuts, and so I'm going to have to recess those holes in the top surface using some Forstner bits so that the T-nuts sit flush with the top surface of the table. After a few drilling and countersinking operations on the drill press, the router plate looks great, and so does the circular saw plate. Now I've also gone ahead and I've tapped in my T-nuts with a hammer. Then you can use a regular hex bolt and washer on the other side to crank those T-nuts down just a little bit farther and make sure that no portion of it is sitting proud of the top surface of the tabletop. Now don't crank too hard because this is just MDF and you could crack it. So now we're looking at this 1/2 inch thick MDF tabletop piece here, which is 24 inches wide by 36 inches long. And I've used my large T-square and the dimensions in the drawing to mark out this rectangular section here, which we're going to cut out. And this is where those plates fit in. Now, all of the drawings I've made available in the description down below, so you guys can find those there. Now, this cut is one of them, probably the most difficult part of this whole build, as we want these plates to fit snug, not too tight, not too loose. I'm going to be using my circular saw to do most of these cuts here. I feel like the jigsaw blade has a tendency to wander a little bit too much, and I think the circular saw blade is a lot stiffer, so I can do the majority of the cut with the circular saw, and then I can come in with the jigsaw on the corners and just finish those corners off. With the rectangular hole cut out of the MDF tabletop, I mounted my circular saw to the bottom of the plate and I plunge cut through that. Then I performed a test fit with the plate inside of the tabletop, and I tried to line up the circular saw blade with the long edges of the table using my large T-square. Now, I use the long edge of the table because the fence will eventually be referencing those long edges, and so I want the two things to be square to one another. I noticed that the blade was ever so slightly off from being perfectly square with those long edges, and then I realized the error of my ways. I was trying to use the rectangular cutout with the plate to line up the saw blade to the edges of the table, when really what I should be doing is lining the saw blade up directly with the edges of the table using the T-square. So what I've essentially done here is created a tolerance stack up, and each of the smaller operations that I performed were off ever so slightly, just a little bit, and that added up to a bit of a larger error. So what I'm going to do now is circle back. I'm going to open up that rectangular opening just a little bit more and give the plate a little bit of wiggle room. And when we come in the next few steps and we introduce the second layer of the table, I can align the saw blade with the long edge of the table using the T-square, and then fasten the plate down to the second layer with the mounting holes, and I'll have a direct reference between that saw blade and the long edges of the table. So now I've slipped in a 3/4 inch thick piece of plywood under the 1/2 inch thick MDF tabletop, and I very carefully lined up all the edges so everything's nice and smooth. And on the right hand side, you'll see that I have a deliberate overhang. So the 3/4 inch plywood is actually 36 inches long, and the MDF tabletop that we were just working on is only 35 inches long. And so I've confirmed here that it's exactly 1 inch of overhang and that the MDF tabletop is not skewed, because we're going to be tracing out that rectangular opening onto the 3/4 inch plywood, so that when we take it off and we start drawing in the rest of the features that we need to cut and drill, we can reference that opening and make sure everything is aligned perfectly. And so the bottom layer is going to be treated in the same way that we treated the top layer, in the sense that we're only going to be cutting out this rectangular hole here. And so I've hashed out that area to make sure that I don't cut along the wrong lines. And we're not going to be drilling any of the other holes that are on the drawing yet. We're going to wait to drill those holes until we bond both layers together. For now, it's just this rectangular hole. And this time I'm going to be using the jigsaw. And so I'm going to start off by drilling a few holes in the corners just for clearance so I can get the blade in and get going on these cuts. After cutting out the smaller rectangular clearance hole on the second layer of the table, I realized that I needed some clearance for other features on the saw, like the handle, the battery, and motor cover, and that sort of thing. So my opening is no longer rectangular, and it's got some extra weird cuts in there that I perform with the jigsaw. But the circular saw will now slip in successfully from the top without any sort of interference issues. We are now ready to bond the two layers together, so I've brought the two layers inside the house because my garage is very cold, and I'm spreading wood glue around on the top of the second layer, trying my best not to get it onto the areas of the second layer which will still be exposed once I put that MDF tabletop on. And so you can see with the top on, the areas that are still exposed, and I'm going to use my square here on that 1-inch overhang on the right hand side to make sure that it is exactly 1 inch before I clamp things up. After clamping the edges, I've used some weights in the center to push the center down while these two layers are being bonded, and underneath I've slipped in some 2x4s at several locations to support that tabletop so that those weights don't induce any sort of bending and warping in those layers while the glue is drying. With the two layers successfully bonded together, we're back and we're ready to drill some holes in this tabletop to mount this plate. Now I have my large T-square clamped to the top surface here, and the edge of the square is flush against the face of the saw blade. And I also went ahead and just made sure that the blade is perpendicular to the table in this direction too. So everything looks good so far, and we're ready to take a drill bit to drill some clearance holes for our 1024 screws here that will mount this plate to the table. And this drill bit that's going to drill those clearance holes is just snug in there, but not too tight, because I don't want to open up these holes anymore. The holes are countersunk for some flathead screws. Right now I don't have those yet, so I just got some number 10 pan heads here that I'm going to stick in after I start drilling the holes to keep everything aligned. So now that we have our drill bit selected, we can chuck it up. And this is a brad point drill bit, so I'm hoping to get a good accurate hole that's directly center with the holes that are already in these plates. So I'm going to drill one hole first. So I just drilled out the bottom right hand side, and I've slipped in my number 10 panhead screw, and you can see that it's quite a tight fit. So it's in there, and this gives us a pivot point about which we can align this thing, and it's already aligned, so I don't have to make any further adjustments, but it holds this thing in place while I'm going to be drilling the next hole up here in the top left hand side. So I'm going to do the one furthest away from the one that I just did. Before moving on to the underside of this tabletop, we have 4 more holes to drill, and these are going to be for mounting the miter saw. Since the goal of this project is to have a table, a sturdy table to mount the miter saw, a table saw, and a table router. And so the miter saw is going to be mounted with 4 3/8-inch bolts, and so we have to drill 3/8-inch clearance holes for those bolts to pass through the table, and we're going to be putting, again, T-nuts on the bottom side to, of course, bolt that down to the table. And so like I said earlier, we already have our hole locations, so I just have a 3/8-inch bit here we're going to start with, and then we can always open it up a little bit more. I'm going to start the holes with the brad point here to keep everything nice and accurate, and I just have this little drill block here that I made with my drill press, so this will guide me into drilling a nice straight hole through both layers. I've got the tabletop flipped back over, so now we're looking at the underside, and you can see the holes here for the number 10 screws to mount those plates, and you can see the holes for the 3/8-inch screws to mount the miter saw. Now we're going to be coming in with some Forstner bits and creating some counter bores to mount our T-nuts. Now this isn't really necessary to do, I'm just trying to take an extra step here to make everything nice and flush and smooth on the bottom side too. But again, this is not necessary. And in hindsight, I should have actually done the
Forstner bit operation before drilling at least those 3/8 inch through holes, and that's because the centering feature on the Forstner bit has really nothing to grab onto now, no material for those 3/8 inch holes because they're so big, and the bits had wandered a bit on me here, but it's not really a big deal since this is just the bottom surface.
And so the last thing you're gonna have to do here before hammering your T-nuts is to measure the outer diameter of the shaft of your T-nut, and then find an appropriate drill bit just to make a pretty tight sort of press fit hole that these things will slide into. And you're also going to want to know the depth, because you don't want to drill that clearance hole right through the whole table. And measure that depth, grab your drill bit that you're going to be using for that press fit hole, and you can use some masking tape here to basically just create a little depth gauge to make sure you don't go too deep.
With the T-nuts hammered into the bottom side, you can come up to the top side, take the appropriate size screw, and you can start drawing those T-nuts into the wood so that those barbs are fully seated. And so the next order of business here is attaching these aluminum extrusions to the bottom of our table. And these are 10 series extrusions from 80/20. They have a T-slot like profile to them on all 4 sides. They are 1 inch by 1 inch square. And we're going to be attaching these along the long edge of the table. I'm going to be using number 6 by 1.5 inch long wood screws. And I'm going to be pre-drilling some clearance holes for those number 6 screws every 3 inches down this profile. So I'm going to be drilling down the center of that channel, and those number 6 screws will pass through and they'll pierce into the tabletop. In addition to the clearance holes, we have 4 more holes to drill into each end of the aluminum extrusions, and we're going to be drilling and tapping those holes for 832 screws. Now, this is on all 4 of the aluminum extrusions. You only see 2 on the table right now. We'll get to the other 2 in a minute. I made myself a 3D printed drilling template to drill those holes, and then I can come in afterwards and tap them, but it's not necessary to create that 3D printed part. I just kind of went the extra mile there.
So now you can see I have my through holes here for the number 6 wood screws to go into the bottom of the table. Now we're not going to be using this slot for anything at the moment, and it is going to be facing down, but I am going to come back in here with a slightly larger drill bit, and it's about the same size as the head of these number 6 screws. And I'm just going to peck at those holes a little bit because I don't have a countersinking bit that fits through these slot edges here. And so I am going to attempt to make a slight countersink for these heads to sink them in as far as I can, just in case in the future I do find a use for this bottom slot. There's going to be no obstruction. So that actually worked out quite nice with that pecking method and a regular drill bit. And you can see one of the number 6 screws sitting in there, and it's pretty much flush with that surface. So now we're ready to turn the profile 90 degrees and make our 832 tapped holes in the adjacent face at one end. So we're finally ready to get this mounted to the underside of the table, and just take note that the threaded holes that we just tapped are on the same end of the table that the top surface has been cut short by 1 inch, and it's going to be the same on both sides. Now I'm going to start on one end and work my way down using a straight edge while I screw in the wood screws to make sure that these faces remain completely flush. Now that we have the outer rails mounted, it's worth mentioning that they're going to serve 3 purposes. The first of which is to provide some additional stiffness to the tabletop. The second purpose is this outer slot here. This is going to act as a guide for our fence that we're going to build in the second part of this video series. And the third purpose is the inner slot, which is going to interface with the outer slot on the inner rail that we're going to mount here like this using some 3D printed guides that I designed. And that's going to allow these parts to slide parallel to one another, because this inner rail is going to support an extension on the table so that we can handle larger stocks of material on our table saw.
And so on the one end of our inner extrusions, we're going to be drilling and tapping those exact same 4 holes that we did on the outer extrusions to those 832 threads. And so you can see the pattern right here. Don't forget that all of the dimensions are available on the drawings, which I've made available in the video description down below. And so on the opposite end of this extrusion, this is where we're going to be mounting that table extension. And so I've marked out locations for drill holes here. There's going to be 3 holes, and they're going to be on a face that is 90 degrees from those 832 holes. And they're going to be clearance holes for number 6 wood screws in the exact same way that we did on the outside extrusions for this table. We're going to be drilling those clearance holes at those 3 locations, and so those are 2 inches apart, and the last one is 1 inch from the end of the face. With all of our holes now drilled and completed, we can start the assembly of this rail system. So I have this 3D printed part that fits into the channels of these extrusions, and we're going to be putting this guide into the inner face of the outer extrusion, and we're going to have that countersunk feature there pointing inwards towards the inside of the table. Once it's in place, we can then take 2 832 flathead screws with a little bit of Loctite and secure those 3D printed guides in place. And so now we're looking at the back end. So you can see that I have another guide threaded into the last 2 holes, and the countersunk faces facing the outside piece when I rotate it back down into the proper position. Now I'm going to butt the 2 pieces up against one another on the front face that we just took care of. There should be no issue sliding that guide into place. And on the back here, I've set this thing again properly beforehand, but you can see that it should slide into the table, and it's actually a little tight there. So I may just back off that second screw just a little bit. And there we go. The 2 pieces slide against one another freely, and there's very little play between the 2. Actually, no play at all. So it's exactly what we want. So now I've used my circular saw to rip a piece of that 3/4 inch plywood to 6 inches wide by 24 inches long. And we're going to take this piece and we're going to put it on those aluminum extension arms that I've extended out of the table exactly 6 inches. We're going to clamp them down, we're going to flip the table over, and then we're going to screw this piece in place through those clearance holes we've made for the number 6 screws. So now you can see the drilling set up here with the clamps. And so I'm going to go ahead and pop in a few of those number 6 by 1.5 inch long screws into this 3/4 inch piece of plywood and secure it into place. So with all 6 screws now in place, we should be able to pull this thing out with relative ease. It shouldn't be too floppy because we don't want this thing just flying around everywhere if we're carrying this table around. There should be a little bit of friction. Now you can see that it obviously stops going this direction. Now keep in mind that we also have those guides fastened to the outer profile and the inner profile. If I were to extend this thing out to its full length, those guides would eventually hit each other and provide a stop in this direction. So this thing is now fully constrained within the table. We are ready to get the 1/2 inch MDF and cut out a 6 inch wide strip of that and bond it to the top side here so that it is flush with the rest of our tabletop surface. And so now I'm going to install these 3D printed T-nut retainers that I designed. And so they just sit on the bottom of the table on top of the T-nuts, and they keep them from getting pushed out. So this is why we used the Forstner bit earlier to create a counter bore so that these T-nut retainers can sit flat on the table and I can secure them in place with some number 6 screws. And the idea here is that the T-nut is upside down, and so when a screw is pushed in from the top side, the T-nut does not fall out of the table. So there's 2 different sizes. There's a small size for the number 10 nuts, and there's a larger size here for the 3/8 inch bolts that we're going to be using to secure the miter saw, and the flat side faces the inside of the table. While we're working on the bottom of the table, I've also installed this 3D printed clasp that I designed, and this secures the extension to the main portion of the table. And this is mainly just for when we're carrying this thing around or even during storage and we don't want that extension to come out. So it just installs with a few simple screws, and this thing is pretty simple to use. You just pull up on the one side, you can pull the extension out, you slam it back into place, and you push that little clasp back down and everything is secure. Our tabletop is really starting to shape up, but now it needs some legs. I'm actually going to salvage these folding legs from this folding workbench that I had laying around. It's broken, I don't really use it much, and I figure I can put these legs to good use for this project. You can, of course, build your own non-folding legs, or you can use something like this if you have something laying around. Even brand new, these things go on sale sometimes for like 30 bucks, so you can grab one of those if you really want some nice folding legs. Now we're going to space the legs out from the bottom of the table about 1.5 inches, just using some scrap 2x4 that I have laying around, and that's just to get a little additional height on the table itself. And I'm going to center the legs over the opening created by those plates that allow us to swap in the circular saw or the router, and that way we still have access to the circular saw or router when we need to make any sort of adjustments. The table is now resting on its new legs, and I'm going to be installing the T-slot style track to the top of the table. I have the extension pulled out a few inches to gain better access to this area. Now, this profile is a 1050 profile from 80/20. It is not the exact same as a standard T-slot profile. It is 1/2 inch high and it's 1 inch wide, and that's why we left that 1 inch difference between the tabletop and the second layer. And so you could fit a standard T-slot track of those same dimensions in this space if you wish. I'm going to be sticking to using these 80/20 profiles because I have a 3D printer and I can design guides and mounts that go inside this profile. To mount this track, I'm going to be drilling and countersinking some clearance holes for some number 6 screws, which will then go into the second layer of the table. And by countersinking them, they should not interfere with any of the tracks or guides or slides that we can put through that extrusion in the future. Now, the very last step here with regards to the construction of the table itself is the staining and sealing of this MDF tabletop. Now, MDF can be a little bit of a controversial material when it comes to being used as a work surface. And this is because MDF can swell and expand if it absorbs moisture. And this is obviously why I'm going to be sealing this thing to avoid this from happening in the future. So you can already see that I've gone ahead and sanded the surface. I've used some 220 grit sandpaper on my orbital sander just to rough things up a little bit. And now I'm coming back in and I'm just cleaning off any of the sanding dust because we definitely don't want to trap that within the stain or the seal. After that, I'm just going to be coming in with this Varathane all-in-one stain and polyurethane product here. It's going to be a satin black. I'm going to apply one light coat to start. And in this video, I've only recorded myself doing the first layer, but I'm going to be doing 2 layers here. And the first layer, like I said, is a thin coat. I'm going to come back in with a 220 grit sandpaper several hours after the first coat. I'm going to rough it back up a little bit, smooth things out, then come back again with a second coat. And I'm going to finish off by sanding with some very high grit 400 grit sandpaper. Now, the product label states that you should wait at least 4 hours before sanding and applying your second coat. In my case, I was working in a little bit of a colder garage, and I found that I had to wait a full 24 hours before I could reliably sand the surface in order for it not to gum up the sandpaper and ruin that finish. And so in between each coat, I waited a full 24 hours, and then after the second coat, I waited another full 24 hours before doing my final sand with a 400 grit sandpaper. So this is just a heads up for you guys. If you are using this product in a colder environment, maybe in a warmer environment, you could get away with that 4-hour time limit. And so I'll leave you guys here with a few clips of the finished table surface.
And so that concludes the table portion of this build. In part 2, we're going to be looking at the fence, the remote battery mount system, as well as some of the accessories for this table. If you guys haven't already subscribed, please hit the subscribe button down below so you don't miss part 2. Now, also don't forget to check out the video description down below where you'll find a link to all of the design files that I used for this project, and I provide them all for free. Thanks for watching, guys.